Hi students, welcome to Future Doctor NEET Academy for the problem solving session in NEET Physics. Topic chosen today is from chapter 11, Thermodynamics. Let's move to question number 1. 1 centimeter cube of water at 1 gram of mass at 100 degrees Celsius is converted into steam at same temperature under normal atmospheric pressure of 10 power 5 Pascal. The volume of stream formed equals 1671 centimeter cube. The specific latent heat of vaporization of water is 2256 joule per gram. The change in internal energy is dash. Formula is del Q equal to delta U plus del W. Here you want to find delta U, that is change in internal energy. Formula change in internal energy, delta U equal to delta Q minus delta W. Delta Q you can find, that is M into L, because latent heat of vaporization is given 2256 joules. Then substitute this here. Delta Q equal to M into L. What is the value of M? M is a mass 1 gram and L is 2256 joule per gram. What you should do is you should convert this gram mass into kilogram, but no need, because 2256 joule per gram. Already latent heat value given in per gram. So multiply by this 1 gram, you will get a same. So no need to convert this gram into kilogram and also this joule per gram into kilogram. Therefore substitute this directly. M is 1 into L. Value of L is 2256. 2256 gives 2256 joules. So this is del Q. Next del W. Delta W equal to P into V or P into del V. P into dV or del V. And pressure P is given how much? 10 power 5 Pascal. That is equal to 10 power 5 into dV. dV is 1671 centimeter cube minus centimeter cube. Minus 1 centimeter cube. 1671 minus 1 gives 10 power 5 into 1671 minus 1, 1670. Okay. Then into 10 power minus 6. That centimeter cube to meter means, meter cube means into 10 power minus 6. Then 10 power 5 to 10 power minus 6, 10 power minus 1. Then 1670 into 10 power minus 1 is 167. That is delta W equal to 167.0 joules. So we found two things. Delta Q we found as 2256 joule and this is 167. Substitute this here. Delta U equal to delta Q 2256 minus 167. And if you simplify this, you will get delta U equal to 2089 joules. That is option B. Option B is the correct answer. I think most of you got this answer. Let's move to question number 2. A sample of 0.1 gram of water at 100 degrees Celsius and normal pressure 1.013 into 10 power 5 Newton per meter square requires 54 calorie of heat energy to convert to steam at 100 degrees Celsius. If the volume of the steam produced is 167.1 cc, the change in internal energy of the system sample is dash. Same formula, that is first law of thermodynamics, delta Q equal to delta U plus delta W. From this, delta W equal to delta Q, no, change in internal energy, sorry. So change in internal energy means delta U we want to find. Delta U equal to delta Q minus delta W. Delta Q equal to, what is delta Q? Delta Q is given as 54 calorie. Calorie convert into joules. 54 into 4.2. That is 225.72 joules. That is 54 into 4.2. That is 1 calorie converted into joules means 4.2 multiplied by 4.2. Then 225.72 joules. This is delta Q. And similarly delta W. Same formula as previous. P into dV. P is given 1.013 into 10 power 5. 1.01 into 10 power 5 into V. What is the value of V? V is 167.1 cc. 167.1 cc minus, what is the volume? Volume is not given, 0.1 gram only given. For water, suppose mass is 0.1 gram, then its volume is 0.1 cc. Okay, directly you can write. So 0.1 V, that is mass is 0.1 means then V equal to 0.1 centimeter cube. Then minus 0.1. Then gives 167. 1.01 into 10 power 5 into 167 equal to, you can write straight away 167 into 10 power 5 into 10 power minus 6, because centimeter cube convert to meter cube. 10 power minus 6, therefore gives 10 power minus 1 as 16.7. Substitute this here. This is in joules. Substitute this here. Then delta Q is 225.72 minus 16.7 gives 208.7 joule. That is your change in internal energy delta U. Option B is the correct answer. Let's move to question number 3. 110 joule of heat is added to a gaseous system whose internal energy is 40 joule. Then the amount of external work done is dash. This is also same. First law of thermodynamics, delta Q, change in heat energy is equal to delta U, change in internal energy plus work done. And here you want to find work done. Delta W equal to delta Q minus delta U. And both the answer is given, both the value given directly as heat energy is 110. 110 minus delta U is 40. Then delta W equal to 110 minus 40, 70. 70 joules. Option B is the correct answer. Let's move to question number 4. The PV diagram for an ideal gas in a piston cylinder assembly undergoing a thermodynamic process is shown in the figure. The process is dash. That is here, which is constant. That is a PV diagram. Pressure with respect to volume. Volume is changing as V1 to V2, increasing volume. But what about the pressure? Pressure is same pressure, constant pressure. Okay, pressure will be constant. So at constant pressure, there is a change in volume, means that is isobaric. What is isobaric? Isobaric process is the process in which pressure maintained constant. So isobaric is the correct answer. Let's move to question number 5. An ideal gas is compressed to half its initial volume by means of several processes. Which of the processes results in the maximum work done on the gas? This is PV diagram. In PV diagram, that is work done in PV diagram is nothing but area under a curve. Work done is equal to area of the curve. Area of the curve. And this is the curve, adiabatic, isothermal, isobaric, and isochoric is 0. And adiabatic is maximum. That is work done in adiabatic is greater than work done in isothermal and is greater than work done in isobaric and is greater than isochoric. Okay, so work done in adiabatic is maximum and work done in isochoric will be 0 as we said. And adiabatic is maximum though. So option A, work done in adiabatic is maximum value, that is the answer. Let's move to question number 6. A monoatomic gas at a pressure P having volume V expands isothermally. What is isothermally means? At constant temperature to a volume 2V and then expand adiabatically to a volume 16V. What is adiabatic? That is, there will be a change in the pressure, volume or temperature, but no heat enters or leaves the system. That is adiabatic. Final pressure of the gas is dash, given gamma value 5/3. And work done, that is isothermal process. Equation of state for isothermal process is PV equal to P1V1. And here, this is for isothermal. Then here V1 equal to 2 volts. Substitute, sorry, 2 volume, 2 times of volume. Then P into V equal to P1 into 2 times of V. From this, P1 equal to VV getting cancelled, then P1 equal to P by 2. And already given data, V1 equal to 2V. V1 equal to 2V. Then PV power gamma equal to constant is adiabatic equation of state. Equation of state adiabatic is PV power gamma equal to constant. It means P1 V1 power gamma equal to P2 V2 power gamma. Then here what you want to find? You want to find P2, final pressure. Final pressure P2 equal to, what is the formula? P2 equal to means P1 into V1 by V2 or V2 by V1? Yes? V2 by V1. No, it's V1 by V2. Because V1 is there, V2 goes there. Therefore, V1 by V2 whole power gamma. Now substitute the value. P1. What's the value of P1? P1 is P by 2. P by 2 into V1. What's the value of V1? 2V. 2V. And what's the value of V2? V2 only given 16 volts. 16V. 16 times of V. Then 16 into V. Then cancel things. Cancel the possible terms. V getting cancelled. Then this 2 getting cancelled. Okay. Oh, and then no, this 2 you can't cancel because power is there. Yes. Wait. Whole power gamma is there, no, so you can't cancel that inside things. P into V1 is 2V by 16V whole power gamma. What's the value of gamma? 5 by 3. 5 by 3. Then now you cancel things. Only VV only possible to cancel. Then 2 by 16. 2, 8, 16. Then what's the remaining thing? P2 equal to P into, and P1 is P by 2, yes. P1 is P by 2. Then P by 2 into 1 by 8. 1 by 8 whole power 5 by 3. We can write as 1 by 3, bring it inside. So 8 power 1 by 3 in whole power 5. 8 power 1 by 3 is cube root of 8. What is the cube root of 8? It is 2. Then equal to P by 2 into 1 by cube root of 8 is 2. Then 1 by 2 power 5. 1 by 2 power 5. 2 into 2, 4. 4 into 2, 8. 8 into 2, 16. 16 into 2, 32. Therefore, P2 equal to P by 2 into 1 by 32. 1 by 32. P into 32 into 2 divided by 2 into 32. 2 into 32 is 64. Therefore, this is equal to P by 64. Which option? Option C. Option C is the correct answer. Let's move to question number 7. The coefficient of performance of a refrigerator is 5. If the temperature inside the freezer is minus 20 degrees Celsius, then the temperature of the surroundings to which heat rejects heat is dash. Formula is coefficient of performance beta equal to T2 by T1 minus T2. Here what you want to find? You want to find T1. Then beta is given. What's the value for beta? That is 5. 5 equal to T2. What is T2? T2 is 20 degrees Celsius. That is minus 20 degrees Celsius. Convert into Kelvin. So what you should do? Plus 273. Then gives T2 equal to 253 Kelvin. That is your T2. Then 5 equal to 253. Substitute the value of T2 by T1. T1 only you want to find. Minus 253. Okay. Then cross multiply this because you want to simplify for T1. Then 5 into T1 equal to 5 into 1 plus 5 into 1 minus 5 into 253 equal to 253. 5T1 equal to 253 plus 5 into 253. Okay. Then 5T equal to 1518. 5T1 equal to 1018. From this, T1 equal to 1518 by 5. Okay. Answer you will get in 303.6, that is in Kelvin. 303.6 Kelvin. Then, but problem in this option is given in degrees Celsius. So convert to degrees Celsius. Oh, that is T equal to 303.6 minus 273. Okay. Then you will get T equal to 30 point something degree Celsius. That is approximately 31 degree Celsius. That is option A. Option A is the correct answer. Okay. Thank you, students. In next session, we will see through other chapter.